Thank you everyone for coming. I'm excited to share with you a couple of research projects, both related to SGMA, the Sustainable Groundwater Management Act. So yeah, I'm essentially going to talk about two different projects. They're both related, but they're drawing. This talk will draw on research from co-authors Nick Haggerty, who's at Montana State, and Andrew Ayers, who's at University of Nevada, Reno. And we've been grateful for funding from a handful of different sources. The first project is trying to look at some of the early impacts of the Sustainable Groundwater Management Act. How are farmers responding in some of the early years of implementation? And I'll dive into what I mean by that exactly. And then the second half of the talk will be about kind of the policy choices and implications of the GSAs themselves, with a particular focus on water markets, which GSAs are proposing them, and what we can learn from one particular adjudicated basin in Southern California that has been trading groundwater for several decades. And I just wanted to flag as well, if anyone wants to, unmute to ask a clarifying question throughout the talk, super happy to take questions as we go along, but I'm also going to try to reserve some time at the end for your questions and comments. And I would welcome any reactions to this. Okay, so for those of you that aren't aware, the Sustainable Groundwater Management Act, kind of dubbed SGMA, was passed in 2014, and it required first the creation of local groundwater agencies that would then work to bring groundwater use to sustainable levels. For the purposes of kind of the analysis that I've been doing, there are a couple of features of SGMA that kind of make it really interesting for studying, and features of it that make it a nice case study. So the legislation gives authority to local groundwater agencies, so it kind of enables them to do a lot, but it's not super prescriptive in how local agencies go about achieving sustainability. And coupling that with the fact that there's variation in groundwater overdraft throughout the state, we'll end up having a lot of variations in both the stringency of kind of future regulation in order to achieve sustainability, but also variation in the policy choices and the management approaches that different groundwater agencies might go about in achieving sustainability. Yet everybody shares this kind of long time horizon with all these basins kind of targeting sustainability by 2040 or 2042, depending on their exact status. The map here on the left is just showing all these high and medium priority basins in California that are subject to the Sustainable Groundwater Management Act. And this accounts, prior to SGMA, we didn't have that much groundwater regulation in the state. And so this represented a really big change from the past. Obviously, it built on past precedent, but overall, this legislation is very comprehensive, with the exception of a few adjudicated basins, one of which we'll talk about. This is covering most of the agricultural regions in the state and accounting for something on the order of 95% of the groundwater use in the state covered under SGMA. So one question we had was whether or not, as now that once SGMA passed and it was kind of on the horizon that there would be regulation of groundwater, whether or not people were responding kind of in anticipation of cuts or regulation, mandates that they couldn't pump, for example, in anticipation of SGMA. And so there are a couple different scenarios that you might expect could happen. So one of which was maybe farmers might race to pump more before their groundwater gets regulated. Maybe you're incentivized to drill your wells now because it could be that in the future there might be limits on well drilling, for example. And on the Alternatively, you could think, oh, maybe there'd be more of a gradual transition to sustainability. If we know that we'll have to achieve sustainability somewhere in the future, we might start making adjustments in advance of that to kind of smooth that transition. Alternatively, some people might say, okay, Sigma's way too far out. 2040 is so far out in the future, it doesn't affect any of my decisions today. Um, and obviously, there's a lot of spatial variation in how Sigma is being rolled out across the state. With some areas already implementing allocations and others not yet, or maybe won't have to at all. But regardless, even before any sort of allocations come into place, you might expect that Sigma could affect certain farm level investments. If you want to think, for example, of well drilling or the planting of perennial crops that might have a really long time horizon. And so it would be fair to think that if you're going to decide to plant a perennial in 2020, say, and you knew about Sigma passing, maybe nothing has happened yet, but you would expect something to happen within, say, a 20-year time horizon, for which you expect your almonds to be profitable. And so maybe that affects your decision making on the margin. Same with drilling a well. These other kind of water related investments that are very forward thinking. You're anticipating what your water supply might be like in the future, and that's going to affect whether that investment makes sense for you today. Um, and some of this was coming out kind of in the public discourse, and we were seeing this in kind of news articles. So this is an article from December of 2021 in the LA Times, saying despite California's groundwater law, aquifer levels keep dropping in a quote race to the bottom. This idea that everybody was rushing to drill wells, and it could this kind of raises the question, okay, was this happening? How does this relate to Sigma? Would this well drilling have happened anyways? Or was the fact that this regulation was in the pipeline might have been affecting incentives to drill new wells early on? Simultaneously, we've been seeing this big increase in perennials throughout California. This is a figure we generated using USDA's cropland data layer, so remote sensing data on land use for the Central Valley. And there's been this increase in perennials over many years now. The vertical line is 2014, and since Sigma passed in 2014, we have seen about a 50% increase in new perennials or in perennial acreage. But of course, that trend predated Sigma. So, one question is like, would this have happened? Would this have been the trend post Sigma if Sigma hadn't been passed, or is Sigma either increasing incentives to plant more perennials, or actually detracting because those investments didn't look as attractive in a Sigma future? So that's the question we kind of want to investigate using, just sort of early years of data. Sigma, of course, hasn't been around that long in order to have many years of data to look at. But so first, I guess backing up, I kind of alluded to this before, but Sigma is just maybe one factor that might influence decisions around perennial plantings or new well drillings. But it's certainly, I would propose, it's not the biggest factor driving those decisions, right? There's so many other factors that come into play when farmers are deciding what plant they want to crop. And I don't begin to pretend that I know what all of those factors are, but I could guess certain things like crop prices are going to be a much bigger driver of whether or not it makes sense to plant a certain crop. And so we want to control for those different factors that are largely unobservable to me as the researcher, and in this study when we're trying to isolate the impacts of Sigma. So I want to just give you a gist of what we do in the data analysis. So you can imagine, I just made this as a toy example. We take two different GSAs that neighbor each other, and you could imagine a a plot of farmland on one side in Turlock, for example, and a different plot in Merced. And you could imagine comparing outcomes on those two parcels before and after SGMA passed. And if you kind of keep those comparisons very close to the boundary, at the boundary, these two parcels in these two different administrative areas are going to be regulated differently under SGMA. If they have different degrees of overdraft, for example, they would have farther to go in order to achieve sustainability. So they're going to be treated differently under SGMA. Yet they're going to face very similar agronomic and economic conditions if they're really close to each other in physical space. They're going to be experiencing the same crop prices. Perhaps their soils are relatively similar. The climate conditions are very similar. And so then if you're making these comparisons kind of right around the boundaries, then we're hoping to kind of isolate just the role of SGMA and control for all these other potential confounding factors that we don't observe, but we know are important to planting decisions and well drilling decisions. So that's the idea. Of course, we also need a measure of the extent to which farmers are anticipating SGMA. And so we're kind of calling this the future regulatory stringency under SGMA. Ideally, we would want to have some measure that captured farmers' expectations of required future pumping reductions under SGMA. And so that, of course, is not something we can observe directly. And so we assemble 3 different proxies for that. We first turn to the groundwater sustainability plans themselves that these agencies have had to submit to the state. And we pull from there what they report as their overdraft, kind of embedding the assumption that they would need to correct overdraft on average in order to achieve sustainability. We also pull from those plans estimates of projected pumping reductions. Those are stated in the plans themselves. And then we took modeled overdraft estimates from C2VSIM. And without a good reason to choose kind of any one of these over another, we averaged across all 3 of these proxies to come up with this measure of what we're calling future pumping reductions. And here's what it looks like over the Central Valley. And so, yeah, you can kind of see on this map where we have boundaries that are, of 2 different colors, right? You can compare farmland on either side of that boundary really close to it, and they're being treated differently in terms of regulatory stringency under SGMA, where you might be expecting greater future reductions on one side of the boundary than on the other. And we're going to use that variation to try to pin down the role of the kind of anticipatory effects of SGMA on these water intensive investments. Okay, so here's what we find starting with new perennial plantings. So we do this comparison, right? I showed you this example of just one parcel on one side in Turlock and one parcel on another side in Merced. But we're going to do this for every single boundary that you see here, like within the greater outline of the Central Valley. And we're going to compare all parcels within 15 kilometers of those boundaries. So taking all of these pairs of neighboring boundaries and limiting them to within these 15 kilometers, we're going to look at changes in the share of land planted in new perennials and graph that over time. And we have 2 lines here. One is for the basins that are in conditions of greater future pumping reductions according to our measure, comparing the share of land in new perennials to those in facing fewer pumping reductions. And we're going to look at this over time. What's grayed out here is 2014 through 2019. And this is kind of the period between when SGMA was announced and kind of these plans were more formalized and have been through kind of the vetting process where we would think it would be reasonable for most farmers to have a sense of uh, the impacts of sigma. And so when we're actually thinking about what are these anticipatory effects of sigma, we're really focused on 2020 and 2021, with the idea being, right, those plans have been formulated and communicated, and so it's reasonable to expect farmers have formed their expectations of future pumping reductions given that information being available. Um, and so one of the, I hope, kind of striking things that you see from this figure is that these two lines trend together very closely, right? And so we're not seeing kind of major differences between um, basins that are facing kind of greater overdraft and greater expectations for pumping reductions under sigma from those with kind of fewer future pumping reductions. Um, and we show this statistically, in the paper where we look at the differences between these two regions in the year prior to sigma and compare them to the differences in 2020 and 2021, and that we don't see anything that's statistically significant. Um, and the story is very similar when we look at well construction as well. So here are we're graphing those trends in new well construction over time for basins that are expecting kind of more stringent regulation under sigma to those that are facing less stringent regulation. Those are graphed in blue. Um, Looking at all neighboring, pairs of neighboring basins, and again, limiting it to just 15 kilometers near the boundary. So we're hoping, trying to make more careful comparisons here that control for all these potential confounding factors. And we find that the trend line is, again, very similar between these two different groups. We see this big spike in new well construction, right, in like 2015. Which coincided with a major drought. So there was a lot of pumping, or sorry, well drilling that was likely happening, spurring a lot of these, headlines suggesting that farmers are racing to drill wells despite sigma passing. And that's all true, but it doesn't look like there was any more well drilling actually happening as a result of sigma, right? It was happening for other reasons, because we see these two lines moving together quite closely, and any differences, the focus of our analysis was 2020 and 2021, and those differences relative to the pre-sigma period are not statistically different. So our conclusion, was that we couldn't find any detectable anticipatory effects in 2020 and 2021. What we were considering, this post sigma period, after farmers have had an opportunity to update their expectations about future regulation of groundwater. Which I think is encouraging from the perspective, if you were worried about perverse incentives from sigma being passed, leading farmers to drill more wells now while they still can, or use as much groundwater as they can now, maybe get your perennials in the ground, so that you could kind of claim a higher rate for when allocations get established, right? You can come up with a lot of these theories for perverse incentives to use more water once sigma has passed. We're not seeing any evidence of that. But at the same time, we're not seeing any evidence of like an anticipatory adjustment towards compliance to sigma either in these early years. But again, they are still early years in the timeline of sigma. So, what are a few possible explanations for that? One of which is just perhaps meaningful cutbacks from sigma are still so far in the future that it doesn't make that much sense to make big changes to your investment decisions in 2020 and 2021. Another possible explanation is perhaps users, or farmers don't believe sigma will actually bite, that there will actually be kind of restrictions in groundwater reduction going forward. Maybe there's a belief that kind of managed aquifer recharge or additional sources of water supply will solve the problems, and so you don't need to make any changes in order to meet sigma. That one we kind of believe less probably, but can't, obviously can't prove that that's not true. I think our leading explanation is just that sigma is still so far in the future, and we all kind of discount things in the future, and so decisions today are still kind of happening business as usual. And by today, I mean 2020 and 2021, which we looked at in the study. Of course, now more years have passed and things have been changing rapidly under sigma. So um, we do hope to continue kind of tracking this and seeing what's happening. So our next steps, we're now working to try to use these other, like OpenET, these other measures of consumptive water use, and try to see how sigma is affecting consumptive water use, particularly now that more time has passed. And so now that we know, like starting in 2022, for example, several GSAs started allocations, and so you might see more of a meaningful reduction in water use now that more time has passed. So stay tuned for more on that front. So at this point, I wanted to switch gears a little bit to talking more about kind of what groundwater sustainability agencies are doing under Sigma in terms of the actual policies they're proposing to achieve sustainability. And in particular, I've been focusing on groundwater markets, which was something that I think um, has received a lot of attention. There's been interest among GSAs in doing it, and there's also been a lot of kind of research interest on the topic as well. But I think it raises a lot of questions. So I kind of already said this before, but Sigma opens the door for local groundwater trading in a way that wasn't really possible prior to Sigma passing. There just wasn't really, you can imagine, there's no incentive for trading when you don't have when the resource itself is more of a free for all, for lack of a better word. Like those incentives aren't there. The Public Policy Institute of California, that has done some estimates of kind of Sigma impacts, suggested that, or first they estimate that in the San Joaquin Valley, they'd be looking at on average a 16% cutback on groundwater use in order to achieve sustainability. And that this could lead to a significant amount of fallowing, and which of course translates to crop revenue losses. And they also did some analysis suggesting that if you could enable trade, both expanded trading of surface water kind of across districts, but also enabling groundwater trading at the local level within different GSAs, that this could put a pretty big dent in the costs of the Sustainable Groundwater Management Act, the cost of having to cut back groundwater use. And so they estimate on the order of 33 to 50%. So that's one reason why I think groundwater markets have been getting some attention as a tool for meeting some of these Sigma mandates. Here's just a quick status update. From my understanding, there might be others in terms of what's happening right now with markets under Sigma, and this is based off of the 5-year reviews that have been now submitted, because it's 2025. So some of the critically overdrafted basins that had to submit their plans first, for those that got approved, they have come now around to their 5-year, the timeline for submitting their 5-year updates, and so we've looked at those. So this isn't fully comprehensive, because for any of the critically overdrafted basins whose plans were not approved, they might not actually have come upon their 5-year review deadline yet. So yeah, here's a map on the left-hand side. Most of these are like southern half of the Central Valley, or kind of southern central Coast, Santa Barbara area. Um, and so these were all, uh, well, all the ones in blue um, were basins that had expressed interest in groundwater markets. The ones in yellow are working on establishing allocations, which of course is a precursor to it is a necessary component if you were interested in allowing trade. You need to have those allocations formalized. So we're also kind of interested in tracking that. Um, but yeah, of some of these blue ones, McMullen area, GSA appear to be kind of stalled in coordinating allocations, but have expressed interest in allowing trade or enabling trade if they can sort out the kind of allocation establishment. Madera County GSA did a virtual market simulation. So they expressed initial interest, but essentially my understanding is kind of deemed it too challenging for a number of reasons, and it doesn't look like they're kind of pursuing it much further, although they haven't totally ruled it out. The West Side allows trading, but there's no kind of formal market or institutional structure for kind of enabling that. So unclear how much trading might actually occur when you don't have kind of a system in place for trying to find trading partners and all that kind of stuff. Fox Canyon, so that's like Oxnard and Pleasant Valley at the bottom of the map there. They were one of the regions that kind of first established any trading under SGMA. But according to their 5-year plans, apparently they've gone to a court adjudication process. And then Mid Kauai, which actually isn't a critically overdrafted one, I don't think, but are just kind of ahead of the curve, I guess, have established a water market pilot and seem to be kind of furthest along in developing a market from what I can tell. But again, this is probably an incomplete picture because this landscape is changing very rapidly, and perhaps some of you all here in the Zoom room know better of other market development happening in the state, and if so, I'd love to hear about it. So, as I mentioned before, from the PPIC studies estimating that further allowing trade could kind of reduce some of the costs of SGMA. There's also a very large literature in economics suggesting that water markets have the potential to generate large efficiency gains relative to more prescriptive policies. And what I mean by that are kind of like allocations that you aren't allowed to trade. So this kind of more inflexible like mandate of how much an individual farmer is allowed to pump. And so there have been lots of studies estimating those aggregate economic gains from introducing trade. But a lot of times that the way those efficiency gains or economic gains are achieved is where kind of high productivity firms acquire more of the rights to pump and then and acquire them away from the low productivity firms. So you could think of things like economies of scale. If a firm has economies of scale and they can kind of they acquire more rights and are able to then produce more with it makes sense to them to buy more from those lower productivity firms it makes sense to them to sell it. So you get these mutually beneficial transactions to those two parties who are participating, but you can have an outcome where there is more consolidation of those permits due to the trade, and that's part of how you achieve these efficiency gains, to kind of produce more with less. But some folks are very concerned about that consolidation, and whether that be like a fear of market power. Maybe if large players are able to consolidate more permits, they might be able to influence the price of permits and maybe take advantage of the smaller guys that they're buying the permits from. You know, there just might be kind of you know, sectoral cultural changes in a region from as a result of trade. Um, and or if, like, for example, small farms happen to be those lower productivity farms who find it beneficial to them to sell their water rights, then we might have a relative loss of small scale farming as a result of trading. Um, and so these concerns have come up. The California Water Commission had produced this white paper about um, the state's role in supporting groundwater trading and suggested safeguards for protecting small scale farming and other things. And I think my impression is that um, the state is still trying to figure out their role in supporting groundwater trading, and figuring out, yeah, where they're going to make suggestions for how these markets may or may not develop. But through this process, these kind of fears about market power, consolidation, loss of small scale farming, um, fears about those who are selling their permits and exiting the market entirely, definitely kind of bubbled up through this process. And so these are some of the questions that we've been interested in for the second paper, in thinking, can we look at the few examples that there are where there has been groundwater trading and investigate some of these concerns: consolidation, market power, exit of small scale farmers? Can we see what has happened particularly in the adjudicated basin of the Mojave Desert? So the Mojave Desert is in San Bernardino in Southern California, and it's home to one of the most liquid groundwater markets. And so it gives us a really nice kind of case study for trying to investigate some of these questions. So we're going to ask, to what extent does consolidation of permits occur due to trade? Um, is there any evidence of market power? Who is selling out? Um, and are they being fairly compensated? At least we're going to try to get at that. Previous research, um, my co-author Andrew Ayers has published a paper already studying the Mojave market, kind of showing both how the establishment of property rights through the adjudication, which bundled the ability to trade those property rights, both recovered groundwater levels in the basin, but then also generated these aggregate economic gains of a really large magnitude. And so there's already kind of research showing that, okay, there are gains from trade kind of consistent with all the other economics research in this space. And so now we're trying to look at some of these other factors that are clearly coming up a lot with the development of groundwater markets under SGMA. So there's really cool data in the Mojave Basin that we're able to use for this study. So we're able to see first, when the basin was initially adjudicated in 1994, we can see how permits, or kind of like the right to pump, was allocated among pumpers in that first year of the adjudication. So we see kind of the person's name and how much of the groundwater pumping rights they were given. And then we can observe the price and quantity for all trades that have happened since 1994 through 2020, and the two transacting parties for those trades. So we can track every single transaction that has happened since 1994 and see how individual traders have accumulated more groundwater pumping rights over time. It's kind of the permanent pumping rights. And then within the Mojave groundwater basin, there are kind of 5 different subregions that I'll show you on a map, and they had different rates for kind of ramping down the initial allocation in order to achieve sustainability. So taking all that information together, what we're going to do is first track consolidation over time, and we're going to define that as the ownership share of the top 10%. So you can kind of think of like the wealth inequality, how we often think about, the wealth of the top 10% or top 1%. And so we're going to take a similar metric, but for water rights ownership. We're going to empirically test for market power, the ability of large players to influence the market price. That's the definition of market power. But we'll have to do that in the temporary lease market, which is has a lot more transactions than the permanent rights market. And then we're going to evaluate the composition and compensation of those who sell out and exit the market entirely. So yeah, as a little bit of background on the Mojave Desert, clearly from this aerial image, a place where there wouldn't be much agriculture if not for groundwater. They had persistent overdraft from the 1940s onward, and this eventually led to this adjudication process in the early 90s, which established a safe yield, the annual ramp down from an initial allocation to achieve that safe yield, and it allocated a water master who would keep evaluating that and approve transfers. And there are lots of different types of parties in this region. It's not all agriculture. There are some municipal water suppliers. There are brokers in this market. There's commercial entities, and there have been some purchases on behalf of the environment. So there's a little bit of everything here. Here's a map of the region and how it's broken up into these 5 different subregions. You can see the bulk of the transactions are happening in Alto, followed by Baja and Centro. This figure shows the Mojave River, but there is very rarely any water flowing in it. So not to be confused, they don't have a surface water. It's all groundwater in this region. So yeah, so that just gives you a sense. And then there's a combination of both this temporary lease market, like within a given year, the ability to pump the water, and then versus the permanent market. The initial rights were initially allocated based on historical water use. So these permanent groundwater pumping rights are called base annual production, or BAP. And so those were allocated by observing the water use over the previous 5 years leading up to the adjudication. And an individual owner was given their initial property rights was the maximum of their use in those preceding 5 years. And so this allocation scheme was actually more favorable to agriculture than the public water suppliers, because they, on average, had more variability in year to year of their water supplies. So by doing it over 5 years, it was kind of favorable to the farmers. That initial allocation, of course, exceeded the sustainable yield, and then they set a schedule for the gradual ramp down. And here's what that ramp down looks like, and it varied by subregion. At first, everybody was ramped down altogether, and then there were some differences by subregion over time. So one of our first takeaways is that this initial allocation based on historical groundwater use was pretty unequal. We found that in that initial water year, the top 10% of owners controlled 65% of the water rights, and the top 1% of owners controlled a quarter of the water rights. And this is not that different from what happened in the adjudication in Las Posas in 2023, where similarly we found the top 10% controlled almost 60% of the rights. Okay, so now we're going to track consolidation of that ownership using the top ownership share. So the share of the BAP, as we're calling it, held by the top 10% or the top 1%. So what we found was that consolidation grew from that initial 65% that came from the initial allocation to up to 75% by 2020. So our takeaway, this seemed, given a 25-year time horizon, this increase in consolidation, what we thought was fairly mild, kind of a 10 percentage point increase. And it's clearly affected by how different regions are ramped down differentially. We also tracked, the number and composition of owners over time. So you can see, starting in 1995, the everyone is an original owner in 1995, and we have a small subset that are municipal, and everyone else who's non-municipal. And as time goes on, uh, some of the original owners are selling their water rights and exiting entirely. And for the most part, that's replaced by new entrants to the market. And then starting kind of in like 2008, it is not being made up with new entrants. And so the total number of owners declines over time. You can see that this green bar is relatively stable throughout, but the yellow is getting smaller and smaller over time. And so that's the exit of original non-municipal owners. And so you can think about, farmers being of those original owners that have been exiting the sample. And roughly half of the original owners had sold out entirely after 25 years. We only observe the names of the owners, so it's relatively straightforward to see who's municipal owner or not, because you can recognize the name of an urban water utility in the sample. But it's harder to identify who exactly are farmers, because you're just largely seeing people's names. So we kind of did that through a process of elimination by reading through all of the names of these 450 owners, and seeing who is municipal, who is commercial. You can kind of tell from the names, and then assuming everybody else is agriculture. So what we find of the sellouts in particular, so we're not talking about people who just sell some of their water right, but sell the entirety of it and exit the market entirely. We find that they're smaller on average. So their ownership holdings of sellouts is about 40% less than those that remain in the market. They're more commonly agricultural users. So the small farms and ranches that we might be worried about losing. But we do find that the prices that the sellouts receive aren't statistically different from those received by other market participants. So if that's your benchmark for fair compensation, they're kind of receiving the same as everybody else. And so we could conclude on that basis that they're fairly compensated. So you might wonder, okay, who is buying up these rights if on average smaller agricultural users are selling? Well, there's been a huge growing urban demand. And so, there's been some population growth, and some of the major municipal water suppliers have needed to buy water in order to support the population growth. So we've seen the share of rights held by public water suppliers in this region increase over time. And so, since market power has been a concern in kind of the public discourse around the development of these groundwater markets, we wanted to test in this empirical setting, can these large municipal buyers influence prices over many small farmers? And I'm going to spare you the details of the econometric test that we do, but we find kind of little evidence of market power. If anything, we find that there could be a markdown of about $4 per acre foot, and this is less than 5% of the transaction price. So we kind of conclude that it's not a big concern in this setting. So to kind of wrap up from this Mojave case study here, these are kind of the conclusions we have from just this one setting. One, the initial allocation was highly unequal. Two, there was some mild consolidation that occurred over those 25 years, with that top ownership share increasing from 65% to 75%. We don't find much evidence of anti-competitive behavior. And we see that about half of the original owners sold out entirely and exited. And they were largely kind of non-municipal and smaller on average, but appear to be compensated fairly. So of course, this is only from one specific area, the Mojave Basin. And so much of this, it's hard to generalize what would happen in other contexts, because so much of it depends on the makeup in the region we're studying. But we hope that this will kind of add to some of the discussion, because we do oftentimes people are talking about the development of markets under Sigma as if we have nothing to go from because it's so new. And I think there actually are a few instances where we have seen trading. In this case, there's been trading for over 25 years, and there's stuff we can learn from it. So I'll just wrap up here. To summarize in general, I'm part of why I'm so excited about the Sustainable Groundwater Management Act, as something to study and kind of work on, is that it has a lot of potential to improve groundwater resources in California, and the way in which that it allows local groundwater agencies the flexibility in figuring out how they want to manage the groundwater is both really great for having policies that's more tailored to specific local settings that make sense in those geographies. And it also opens a lot of questions about what are the best policy choices, and what are the different kind of implications of different approaches. I think trading has garnered a lot of interest, both in the economics kind of research community, but also in the Sigma policy space for various reasons. I think there's potential for markets to lead to aggregate increases in well-being, but there's also a lot of uncertainty on how it would unfold, and who would be impacted more than others. And so there's still a lot of questions to ask there. So anyways, that's all I've prepared, and I'm really excited to hear your comments and feedback. Thank you so much.
Thank you, Ellen, for your insightful presentation. I think we have 10 minutes for question. So please unmute yourself if you have any question, or put in the chat.
I've got a question.
Please.
It seems like, I don't know the numbers, but it seems to me that there have been more adjudications, like by number, than there have been markets implemented. And the Mojave example is like one of the few ones that have been going for a long time. Is there any way to use, I guess, adjudications? Are those allocations more fixed? Do some of them adapt over time? Could we use adjudications as a different data set for how these things evolve?
Yeah, great question. I have not really dug deeply into any other adjudications. Like Mojave is kind of the first setting that I've been studying. My sense is that they're not, like in the Mojave case, they decided to enable a market as a part of that adjudication, and I think other ones could and others couldn't. The reason I kind of mentioned that with Fox Canyon was just part of one of the conclusions I'm kind of drawing from seeing the landscape of groundwater market development under Sigma is that it seemed to be really challenging, and for any number of reasons that are kind of hard to see as an outsider, right? But in Fox Canyon, that one had kind of been held up as like, that's the first market to trade under Sigma. And like in many cases, people were talking about it as the poster child for different reasons. And then to see that it went to an adjudication process was kind of another signal of like, wow, this is really hard to do. Maybe under the adjudication, it could still lead to trading if that's something that I think people in the region want to have. I don't really know how the process is going to work. But somehow the market that they had set up originally wasn't working, and just kind of observing that happening.
Yeah, thanks.
Any other question? So I have one question, Ellen. You mentioned water market have the potential to increase efficiency. So do you have any quantification, observation, or any estimation in one or a couple of regions you worked, or any idea which percentage or how it improved the efficiency?
So how those gains are achieved, or the magnitude of those gains?
Yeah, the magnitude.
The magnitude. Yeah, I mean, only kind of off the top of my head, I know my co-author had done this study in the Mojave Basin itself, and I think I had that in here somewhere. Right. So he was estimating aggregate gains of over 400 million. I think there are other ways that you can kind of represent the gains from trade in terms of like percentages that might be more digestible. I don't think I have other kind of figures off the top of my head. But in some other work with several co-authors, we've been reviewing the literature on papers that try to estimate the gains from trade, right? And kind of universally across this body of literature, they tend to be positive and large. And I think that's part of why so many economists like turn to them as like, oh, well, this seems like a obvious policy tool for achieving sustainability, because it can kind of, whichever way you want to frame it in terms of reducing costs or generating gains relative to prescriptive approaches.
Thank you. I think Safiq has a question.
Yeah, hi, Ellen. Nice presentation. Just kind of coming back to the chart which you showed for the Mojave, where the individual water right holders, or the number of individual water right holders, was going down. And I'm just wondering, is it a result of consolidation, or they're selling the land? What is happening on the ground?
Right. Yeah. I mean, I think it is a result of this consolidation where, a fewer number of owners are holding a greater portion of the rights over time.
So they're buying out the land, or?
So in this case, the right to the groundwater is separate from the land.
Okay.
So not necessarily. In some cases, yes, but.
Interesting. Yeah. And I don't know, maybe I'm reading too much in this since you have the chart in front of me. It seems like even the municipal, I'm looking at the height of the green, is kind of shrinking, but maybe I'm reading too much.
But there's also like these newcomers in
I see.
in municipal, yeah. So it's a little hard to read. But definitely the municipal owners have been increasing their ownership share over time.
Yeah, thanks.
So any other question? We still have a couple of minutes.
If I can take another one, what do you think are if you had to like cast your gaze across California, like what would be your next top case study or place where this is playing out in ways that are either generalizable or so specific as to be super unique?
I mean, I'm definitely interested in, I feel like there's some interesting stuff happening in mid-Kauai. I'm just gonna, in terms of water market development specifically, it kind of seems like they're the next place to watch, in the same way kind of Fox Canyon was one of the first movers. I mean, I'd still be interested in kind of following what happens with Fox Canyon and the adjudication process, but it seems like mid-Kauai, from my view, that they have kind of made the most progress in terms of developing a pilot project that seemed to lead them to kind of want to develop it more fully, as opposed to do a pilot that led them in the other direction to not try to do it anymore.
Okay, I think I don't see any question.
Yeah, well, thank you all so much, and thanks for your questions. I really appreciate the opportunity.
Thank you very much, Ellen. Again, we appreciate your presentation. Thank you everyone for joining us. As I mentioned, we will have the next webinar November 3, and we will share the topic. Thank you everyone. Have a good rest of your day. Appreciate it.